Hey everybody, Daniel from Spacedock here. You may have heard the term Lagrange Point come up from time to time in certain works of more grounded science fiction. For example, in the 7th Expanse book, Persepolis Rising, or in the sci-fi anime Planet S. I'd like to take this short video to explain exactly what a Lagrange Point is, and why it can be such an interesting concept for use in science fiction. Any system of two large objects in space, such as the Earth and our Sun, will produce 5 points of stability where the gravitational pull of both objects cancel each other out to create a small area where stations or satellites could be kept at a relative halt without the need for control thrusters or orbital correction. This segment will use the Earth-Sun Lagrange points as an example, but systems of 5 points such as this exist between any two objects, for example the Sun and Jupiter, or Earth and Luna. On a direct vector between Earth and the Sun, and a short distance from our planet, lies Lagrange 1. This is the point where the direct gravitational influence of the Earth and Sun cancel out. On the same vector, but beyond Earth's orbit, lies L2. The Earth's gravity well maintains the position of L2 in spite of its higher orbit around the Sun, which would normally cause an increase in its orbital period. Lagrange point 1 is particularly useful, as it allows for a satellite placed there to not only remain equidistant from both the Sun and the Earth, but also provides a position for a consistent visual feed to the Sun and the illuminated surface of the Earth. One such example of a satellite placed at L1 is the Solar and Heliospherical Observatory, or SOHO satellite, which has provided us with information about complicated gas currents below the Sun's visible surface and tracked changes in its magnetic fields. The third Lagrange point is located on the other side of the system, far beyond the Sun. This is the point where the Sun and Earth's gravitational pull align in the opposite direction to L2, and an object placed there would remain eclipsed by the Sun and completely hidden from the Earth. Practically speaking, this would mean that it would be very difficult to maintain communication with one such satellite, and as of now, scientists have not yet found a use for L3. In science fiction, however, it would make an excellent spot to hide, say an alien base, away from the prying eyes of unsuspecting Earthlings. Lagrange points 1 through 3 are considered to be metastable, meaning the objects placed there will remain in position so long as they are never influenced by any other forces or nudged out of alignment. For this reason, a station or satellite would still need some manner of control thrusters in order to correct its position should it be affected by another object's gravity or otherwise misaligned. This is not the case with Lagrange points 4 and 5, which are located by charting equilateral triangles above and below the direct vector to the Sun to find the gravitational barycenter. L4 and L5 points are extremely stable gravity wells that pull objects into themselves. Certain asteroids have been captured naturally by these wells, and sizable asteroid fields, known as the Trojan fields, exist in the L4 and L5 points between the Sun and Jupiter. Lagrange points 4 or 5 between Earth and the Sun would be perfect locations for large spaceborne colonies or other superstructures, as they would require no delta-V or orbital correction to maintain their position relative to Earth and the Sun. This would allow huge stations to be built, with no concern given to their thrust-to-mass ratio or correctional thrust abilities, with the structure maintaining station keeping as a natural side effect of its location. The distance and travel times between Earth and this facility would always remain the same, even as both objects continue to orbit the Sun, creating a simple trajectory for resupply and passenger transport between them. Systems of 5 Lagrange points exist between every pair of large objects in space, and scientists are still developing plans to take advantage of these phenomena. As soon as 2021, the James Webb Orbital Space Telescope is scheduled to be deployed at Earth-Sun Lagrange 2, and a number of satellites are already in place at Lagrange 1. The potential uses of these locations are many and extremely exciting. Imagine an orbital shipyard facility constructed at Lunar Lagrange 5, a place where supplies could be sent along a direct vector to assemble spacecraft in high Earth orbit at the same distance as the Moon, freeing us from ever needing to use costly and inefficient rockets to break Earth's atmosphere, and allowing for much larger, long-range spacecraft to be assembled and launched. This is Daniel from Spacedock, signing off. Thank you for watching Spacedock. Please remember to like, subscribe and share for more science fiction spacecraft summaries. If you enjoy the channel, why not consider pledging your support on Patreon? For just $1 a month, you'll be able to access the Spacedock schedule to see what's coming up.